Hello everyone. So in the previous video, we have discussed about the standard normal random variable or standard normal distribution and normal distribution, and then we wanted to solve a couple of examples, right? So we have started with an example, and we will do a couple of more examples like that. So again, I wanted to discuss the previous problem. So look at this problem. What it asks that if x is a normal random variable with parameter mu equal to 3 and sigma score equal to 9, find this probability, right? So our aim is to find the probability of this, but we have seen that normal random variable, the probability density function is e power minus x square by 2. So where integration is very difficult, so what we do in that case, we will convert it into the standard normal variable, and then we use the standard normal table to find the probability, right? So how to change the standard normal variable? So you have to take z equal to x minus mu divided by sigma. So if you do this transformation, it will become the x will become the this z will become the standard normal. That means it's a normal random variable with parameter 0 and sigma equal to 1. Okay, so let us do this problem again. So we have to find the probability of this one, probability of 2 less than x less than 5. So what we'll do, we'll convert this x2 into the standard normal random variable. So what we'll do, here mu equal to 3 and sigma is what? Mu is equal to 3 and sigma is also 3. So we'll convert it. How? So p of 2 minus mu, so 2 minus 3 divided by sigma is also 3, which is less than x minus 3 divided by 3, which is less than 5 minus 3 divided by 3. And therefore this value is p of minus 1 by 3 less than z less than 2 by 3, right? And then once we have this, because this is the standard normal variable z, and we know that phi z is its cumulative distribution function, so this value is equal to phi of 2 by 3 minus phi of minus 1 by 3. These things we have discussed in our lecture class. And then this value is phi of 2 by 3, but this negative quantity we don't have the value, but we know the formula. What was the formula? That phi of minus x is equal to 1 minus phi of x. We will apply this one. So this is 1 minus phi of 1 by 3, right? So phi of, now if I just do the in decimal, so it is 0.67, correct up to 2 decimal place, minus 1 plus phi of 1 by 3 is what? 1 by 3 means 0.33, right? Now we have this value from the standard normal table. I'll show you again how to do this value, how to find this value. Phi of 0.67, we can get it from the standard normal table. Yes, so 0.6 is here and 0.7 is here. So 0.67 you'll be getting from this value. So this row, you have to go through this row and you have to come to this column. So this will be the value, right? So 0.7486. And phi of 0.33 we have to get. So 0.3 is somewhere here, 0.03 is here, so we have to go this way and come to that. So this will be your values, phi of 0.336, 0.6293, right? So now go back to the actual problem. So this value is phi of 0.67, we already find out, 0.7486 minus 1 plus phi of 0.33 is 0.6293 from the table. And after that, if you just simplify it, you will get this value. It's 0.3779. So we got the solution of this problem. Done. Now the next part is part B. This asks that what is the probability of x greater than 0. Now again, we will do the same method. We will convert this x into the standard normal variable by doing the transformation z equal to x minus mu by sigma, where x is equal to, where mu is 3 and sigma is 3. So what will happen then? Again, p of x minus 3 by 3 is greater than minus 3 divided by 3, 0 minus 3 by 3, right? So now this is actually z, so p of z is greater than minus 3. And then we can also say that this is by probability calculation 1 minus p of z is less than or equal to minus 1. But again, we know that this is 1 minus phi of minus 1. But phi of minus 1, we can write it as 1 minus phi of 1. So this is equal to 1 minus 1 plus phi of 1 by the property of this one. Right? So this is basically phi of 1. Right? So this is equal to phi of 1. Now again, how to calculate this phi of 1 value? Go back to the standard normal table. So phi of 1 is where? Somewhere here, but it is not only that. We have 1.0 basically 1 means. So we have to get this value only. So 0.8413 from the table. So if you put the value, we'll get the answer is 0.8413. Problem is done. Now we have one more component of this problem. This one is this. So we have to calculate the value of P of mod of x minus 3 is greater than 6. How to do this problem? Now mod of x minus 3 greater than 6 means what? You can do it in three ways because the modulus value. So if your x value is greater than 9, then mod of x minus 3 is always greater than 6, right? So this is actually mean that x is greater than 9. Also, if you have x value is less than minus 3, if x value is less than minus 3 means minus 3.5 or minus 4 or minus 5, all these things if you put, the modulus value is again greater than 6, right? So we can have this one is actually, this is plus x is less than minus 3. If you have both the case, the modulus of x minus 3 must be greater than 6. Now we need to get the calculation of this one, but again, this can be done by converting x to a normal variable. So we'll do that thing. So x minus 3 by 3 is greater than 9 minus 3 by 3 plus x minus 3 by 3 less than minus 3 minus 3 by 3. And then this means p of z must be greater than 6 by 3. So 2 plus p of z must be less than minus 2. And then some calculation again. P of z greater than 2 is basically 1 minus p of z less than or equal to 2 plus p of z less than minus 2. And then p of z less or equal to minus 2 means 1 minus phi of 2 plus this one is phi of minus 2, but minus 2 value we cannot calculate, so we'll apply again the same formula because we know that phi of minus x is equal to 1 minus phi of x. So this value is 1 minus phi of 2, so therefore we got this value, and therefore this value is 2 minus 2 into phi of 2. But phi 2 value how you will calculate, because in general thing we cannot do integration. So again we'll do the standard normal table. We'll go back to the table. So phi of 2 is here, 2 means 2.0. So we have this value is 0.9772. Right? So we'll apply that to our problem. So this value is 2 minus 2 times. What is the value? 0.9772. And finally, if you just do this calculation, you'll be getting this value as 0.0456. So this problem is done, right? So what we have learned that if the normal random variable is involved in some problem, and if you need to get the probability calculation, So usual method will not work here because of the density function. So integration is not that easy. So we will convert this normal random variable by transferring it to a standard normal random variable, and then by using this normal distribution table we can get the probability. I hope it is easy, right? So we have a similar problem like that. Look at the problem, and can you please calculate the value, what you can do, so that these things in same way one can do. So P of A, just for your practice purpose I keep a similar kind of problem. P of 1 less than y less than 9 you have to calculate. But what is y? Y is a normal random variable with parameter mu equal to 5 and sigma square is 16. That means sigma is 4. Right? So mu is equal to 5 and sigma is equal to 4. So how to do this problem again? So we'll convert this y into a standard normal. 1 minus 5 divided by 4 less than y minus 5 divided by 4 less than 9 minus 5 divided by 4. So P of minus 1 less than z less than plus 1. P of minus 1 less than z less than plus 1. And therefore this value is uh, phi of, because it's a standard normal, so their cumulative distribution function, you can write it in terms of that, minus of phi of minus of 1. So phi of 1, again the same formula, 1 plus phi of 1. Right? So 2 phi of 1 minus 1. And how to calculate the phi of 1? We have already done. Phi of 1 is 0.8413. Right? So we'll apply that thing. So 2 times 0.8413 minus 1, and then finally if you just do the calculation using calculator, maybe 0.6826. You can easily do this problem. Similarly, we have the part B here. This one I'm not going to do it. P of y less than 3. Can't you do it the same way? P of y less than 3. So please do it. And finally we'll be getting the answer as, hopefully we'll be getting the answer as 0.3085. So you verify this one. I have not done it. Just do the same way. I wanted to do the third part. So here you have to calculate the probability of mod of y minus 5 is greater than 4. So when you can say that mod of y minus 5 is greater than 4, so whenever your y is greater than 9, you can say that modulus value is that. So y is greater than 9, this is one case. Or if you have y value is less than 1. Less than 1 means maybe 0 or 0.5. All this value p of y value is greater than 4, right? So you can say p of y is less than 1. So for these two cases, you will have mod of y minus 5 is greater than. And after that, it is again the same thing. We have to convert it into a standard normal variable. And we can do the same. So P of y greater than 9 is y minus 4 by, sorry, y, because mu is 5 here, na? So y minus 5. P of y minus 5 by 4 is greater than 9 minus 5 by 4 plus P of y minus 5 by 4 less than 1 minus 5 by 4. And this thing is equal to, that means P of z must be greater than 1 plus P of z must be less than minus 1. Z greater than 1 and z minus 1. And after that again you can do the same approach and then do the write down in terms of phi, right? And then you'll be getting the answer. So I'm not going to do it. You finish this problem, just you practice. Finally you should be able to get the answer as 0.317. So you do the problem in the same way, and then you should be able to get the answer is this one. I hope you understand. Okay. Then I have another interesting problem, which is I wanted to do this one. Now here what it says, let x be a normal random variable with mu is 12 and variance is 4. Now you have to find the value of c such that x greater than c is equal to 0.1. So that means what? Here the probability is given. You have to find a variable c for such that x greater than that value is 0.1. Right? So again, we need the help of the standard normal table, but we have to get the help in a different way. So we that normal x is a normal random variable with mu is 12 and variance is 4, right? So variance means sigma square is 4, so sigma is 2. So we have to convert this x into a standard normal one, right? So z equal to, basically, to convert it we have to do it that z equal to x minus mu, so x minus 12 by sigma is 2. Then it will become the standard normal one. That means, and standard normal one, mu is, that mean is 0 and variance is 1. So it is given that p of x greater than c. So I wanted to convert it into standard normal. So x minus 12 by 2 is greater than c minus 12 by 2. And that means p of z is greater than c minus 12 by 2. Right? But this probability is given as 0.1. Therefore, this value is equal to p of z is greater than c minus 12 by 2 is equal to 0.1. Now I just wanted to do, okay, one more thing we'll do. Z is greater than that, so can I write that p of z is 1 minus z is less or equal to c minus 12 by 2? This is equal to 0.1. But this value is what? 1 minus phi of c minus 12 by 2, which is again 0.1. And therefore, phi of c minus 12 by 2 is equal to 1 minus 0.1 is equal to 0.9. Got it? So therefore, what we got, that the phi of some value is equal to 0.9. So for what value of phi we'll get that is 0.9? We'll see in the standard normal table again. So look at the table where 0.9 is there. So here it is close to 9. What is the point? This is also close to 9, right? This one is close to 9. This one is also close to 9. 0.9. Which one is more close? This one from 9, which is up to 15, and this one. So this one is very close to 0.9, right? But it is whose distributional value? This one is the like 1.2, and this way it is 0.8. So therefore, phi of 1.28, this value is 0.9. Correct? So 1.28, phi of 1.28 value is 0.9. This is more close to 0.9. So we'll do that value. And therefore, if I move to the problem again, therefore, c minus 12 by 2 is equal to 1.28. Because phi of 1.28 value is 0.9. Or maybe I can write it as phi of 1.28. Therefore, c minus 12 by 2 is 1.28. And then c value is what? If you just do the calculation, it is 14.56. Done. So you got the value of c. So here also we have used the standard normal table, but in a different way. Here probability is given. You have to find that x value whose cumulative distribution is 0.9. I hope you enjoyed this problem. Therefore we understand that these are very easy kind of problem. We have to use the standard normal table, and this standard normal table you don't have to remember. It will be provided in the time of exam or any standard book. in the question paper or somewhere in the internet. It is available, right? I hope you enjoyed the video. We'll meet in the next video. Thank you very much.